Whether by a massive solar eruption or successive smaller storms coupled with a weaker magnetic shield around the Earth, one of the end results of this ongoing geomagnetic excursion is that at some point during this field reversal process, the solar wind induction and charged particle bombardment is going to end the modern world. The clock is ticking on various geophysical and heliophysical cycles, and while we believe there is about a 1 in 4 chance of such an event happening this coming sunspot maximum, 2021 to 2026 or so, the field continues to weaken, and that risk is expected to rise over the coming few decades until finally the electrical reset occurs. It is our opinion that it is likely to come on in increasingly severe waves, at first with extreme aurora during inclement space weather coupled with satellite anomalies, errors, and breaks. This is also where we begin to see large networks struggle, everything from airline computer systems to the PlayStation Network. We'll then begin to see the 5 to 10x or more increase in electrical fires and transformer explosions as the core joint vulnerabilities in the grid are exploited by the induced electric current. We'll then begin to see the larger effects. Entire grids begin to shudder, as happened in Quebec in 1989. Wire fires become more common, including in non-energy related infrastructure like skyscrapers and even residential homes. Driverless cars, airline navigation, satellite coordination all become severely degraded, if not crippled. The battery explosions in phones and cars are going to skyrocket, and before long, you'd be forgiven for thinking that we were in the movie The Core, where the collapse of Earth's magnetic field triggers tremendous lightning storms that would cripple the grids anyway, if there's anything left of them. And while that movie was largely nonsensical in the second half, it's really not so inaccurate in how it would all go down. From animal navigation to severe weather to the inability to sustain electrical wiring without melt, arcing, and fires. And we're back to the pre-electric age at that point. If you haven't gone through this mental exercise before, it does take a while to process how you would react in such a situation. No power, no heat, no air conditioning, and no water from the tap. No phone, no fridge, no ATMs, no gas pumps, no store functionality, and no refrigeration if they had it, and no gas for the trucks if they had that, and that includes the trucks needed to fix the grid and the coordination it would take and the facilities that make all the parts. No way to come back at all. There are many contingencies for natural disasters of every kind in almost every part of the world. There is no plan and no possible plan for a disaster hitting the entire planet at once. It's simply over. Let's go ahead and review some of the core information from the believed to have caused a brief 3-degree spike in temperatures, which evened out into the night side atmosphere, the oceans, and then out into space. They believe the 1859 solar storm produced a similar spike of about 7 degrees on the day side of the planet. Now, there are numerous pathways for the particles to complement the strong spike in light energy. The field compression pushes Van Allen belt particles into the atmosphere. The global field disruption induces current through the crust and atmosphere, creating more Joule heating. The proton surge along the interplanetary magnetic field sneaks past the magnetosphere and into the atmosphere, and the increase in energy to the global electric circuit adds a weak Joule heating, but it bleeds out across the entire vertical atmospheric column. The peak events on our star are the superflare and the micronova, and while one brings more heat and the other blocks out the sun for weeks to trigger an immediate ice age, their initial interactions with Earth's field remain the same, a powerful plasma shock wave impacting Earth's magnetic field. Now here's where the compression, coupling, and juicing up hopefully doesn't lead to a collapse and arc discharge of the field. This is what happens on magnetars. Normally, the toroidal field arcs take the current far enough from the surface that the plasma is going to take the path of least resistance through the arch itself. But every step closer during compression and every added bit of energy makes a direct downward arc seem much more attractive to the electric material. Now, while we can't reproduce the power of such current in the lab, Billy Yelverton has demonstrated that not all material of the crust is going to behave the same way. Some resists, some is conductive, some are porous, some layers accumulate energy. While the vitrification and land carving are hard to achieve at residential level power supply, you can learn a lot about how the electricity seems to have a mind of its own for finding the tiniest cracks and pathways, often giving themselves away by peeking out of other cracks and crevices. In addition to affecting every bit of metal in the ground, the crystals in the ground seem to have an affinity for motion upon discharge. Once they have accumulated charge, rapid discharge of the current causes electrodynamic gyro acceleration of some of the pieces. And of course, there is also the water, abundant in the ground and the atmosphere. And as you can show your kids after rubbing a balloon on your head, static attracts more than just dust. In fact, water can't help but scream towards the current and move with it. Billy got more advanced on this side of things as well. Even without glow mode discharge, the application of a merely weak field and current can make the water move and jiggle. If there is enough current, you will begin to see how the water becomes the current shadow, and for those who know water is a polar molecule, perhaps this doesn't surprise you. But now think of the clouds, the rain, the ice, the hail, the flooding, and the large-scale, possibly continent-sized push of metal, crystals, and water underneath the ground. Even the gravity of Earth isn't going to stop the waters below, pushed down by countless tons of pressure per square inch from above. The water is going to be pushing right back. The worst day in recorded history for technology, weather, seismicity, and volcanoes would be that day. And obviously, as bad of a day as a micronova or superflare would be for Earth, our field is weakening quickly, and at the weakest our field is likely to get during the current weakening and excursion process, a normal CME might be enough to do it. With the ultra-rare events always in our mental periphery, the second question becomes, how weak is our shield? How far along into the shift are we? And what level of space weather is it going to take for Earth to have its own magnetar discharge? This is the anxiety with which we watch as the sunspot cycle seems to be beginning again. I am very anxious for the sun to throw something our way, test how our field reacts. I'm potentially more anxious that the test will be too much. Now, most 11-year sunspot cycles have at least one X10 solar flare, about 5 times 10 to the 31 ergs of energy. Something like an X20, slightly smaller than the 1859 Carrington event, occurs about 30 to 40% of 11-year sunspot cycles. Something the size of the 1859 solar storm is a centennial-level event, about every 100 years or so. Something like the Charlemagne event is a millennial-scale event, every 1,000 years or so. While rare in general, we are within the expected return range for those largest two events. So let's look below that to the X1 to X30 solar flare risks. Each colored line here is the magnetic field risk for that flare based on the field loss, which is why 0 is at the top of the y-axis. That's like 100% field strength. So, the blue line, X1 solar flare, is almost never going to have much of a chance of collapsing the field. Even in a total field reversal situation, it might only be a 50-50 proposition for collapse. On the other end of the scale, in magenta, the X30s are going to have a very good chance of collapsing the field even when that field is at full strength. That's why the line begins around that 50% range, because even at full strength, something stronger than the 1859 storm could indeed be enough. And so right now, with Earth about 20% down in the magnetic field, which I'll put in a rectangle here for the general range we're in now, this will tell us where the intersecting flare lines would fall in terms of representing a field collapse risk to Earth. Of course, you could easily imagine 30%, 10%, 50%, 80% field loss. The point is to find the line intersections and then trace that down to the bottom, the x-axis, to find where that intersection falls in terms of chances of ending it all. At the end of the day, given the expected activity this coming sunspot maximum, the approximate strength of Earth's magnetic field, we have about 20 to 25% chance of a superstorm from the sun this cycle, one that gives us the field collapse, the grid collapse, or both. These applications are easier to consider when contextualized in this way, but there is also the consecutive impact scenario with multiple solar storms and feet to the fire. This is probably the reason I would lean closer towards the 25% chance of a superstorm affected Earth this coming cycle, rather than the 20% lower end of the range we gave in Part 3. In this scenario, we are looking at multiple smaller blasts in succession, at least we hope so. If there are multiple larger blasts, things get scary pretty quickly. Now to consider this, we don't shift the curves, we consider a lower field strength range based on the geomagnetic storm. The practical reality of CME impact and geomagnetic storm is a destabilized and generally weaker field. So let's say we took an X3 or 4 solar flare and CME impact, potentially causing a KP6 or 7, level 2 or 3 geomagnetic storm. The second box is the likely range for the strength of Earth's field to consider during that scenario. Now let's say we took 2 hits from that powerful of a flare, or perhaps 1 hit from say an X10, maybe with a KP8 or level 4 geomagnetic storm. Perhaps then we would have to consider the field to be down closer to 50%, or the third box. Now, to give you a better idea of how this works, let's consider 2 examples, represented by the black and white stars here. Now for the black stars, the top one on the left would be the risk we are in now, but if we got hit by 2 of them, as we said, we jump down to the bottom box, and yet there's another one on the way, which posed very little risk with a full field and even a negligible risk at our current 20% down field strength. Another such event, however, we start to move down the curve and present a higher risk of collapse. Now with the white stars, we're looking at bigger flare scenarios, perhaps one titanic sunspot firing 2 X15 flares back to back. This is where things start to get too complex for a simple chart. We could have coronal hole streams, filament eruptions, and solar flares, and it's not likely that numerous consecutive solar flares are going to be exactly the same strength, and so it's really not so nice and clean. But how about a conversion chart? KP index to field loss percentage. There would be virtually no effect before KP4, which is where instability in the field begins, and as geomagnetic storms scale up, this can be a great approximation of where on this chart we would find another impact's risk of that collapse. Now it's important to know that this applies for when the impact occurs at Earth, not when the eruption leaves the Sun. And that's another point. This enhanced risk only lasts as long as the geomagnetic storm. We should probably use both of these charts throughout the upcoming sunspot cycle and hopefully be able to adapt them when we get new information about the field. Super flares might be rare, but with a weaker magnetic field at Earth, we don't need one, and the space weather it will take to cause the worst of the effects, in truth, is just not terribly uncommon during sunspot maxima, at least now that our magnetic field is at this state. So as the coming sunspot cycle unfolds, we will indeed be using those charts to determine consecutive impact risks, or the risk for singlet events of the bigger ones if they come. It will be helpful to know those risks, and also how far down the previous impacts have taken us. The difference between the bottom 2 box risk profiles is no small matter. This is why we watch the sun diligently every day, and this is why we've made those extra tools for us all to use along the way. A certain amount of mental toughness is required for just examining this information. Much more toughness if it actually occurs. But never forget that we are stronger together, no matter what the world lays down before our eyes. The good, the terrible, the inevitable future with Earth's weakening magnetic field. Be safe, everyone.